Hello everyone, today we are going to derive one formula for horizontal thrust of two hinged arches. In this arch, L is the span or total length of the arch and H is the rise of the arch. In this arch, I am going to take a point randomly. From the point, I am going to make an element. In every direction, we are having the values dx, dy and ds, and the angle is theta. Here we are going to find out the cos theta value. We know that cos theta is adjacent side by hypotenuse side. In this triangle, the adjacent side is dx and the hypotenuse side is ds. We can apply. Then we can take the ds on the left side, it will come above, and take the cos theta on the right side, it will go down. Also we know that 1 by cos theta is equal to secant theta. Finally we are getting ds is equal to dx secant theta. In this arch, I am going to take moment at this point. The distance is x meter. So the moment will be m0 minus hy. The term m0 represents the moment without considering the horizontal thrust. You can see the horizontal thrust on both the sides of the arch. So m0 or m0 means the moment without considering the horizontal thrust. So we can say that the m0 means the moment by the vertical loads. If you still don't understand what is m0, we can consider a simply supported arch. In the simply supported arch, there will be no horizontal thrust. So when I calculate the moment at x point, it will be Va into x, because we are having only the Va value up to the x point. So you can take in this way also. When we are calculating the m0, we are assuming that the arch is simply supported, because we are not taking the horizontal thrust. Now we are going to see the two-hinged arch with the horizontal thrust. In this arch, I am going to take moment about x. The reaction Va is acting towards x in the clockwise direction, so positive, and the distance is x, so Va into x. When the horizontal thrust comes, we have to multiply with the height, because when the load comes, we have to multiply with the perpendicular distance to get the moment. For the horizontal thrust, this is the perpendicular distance because it is 90 degree, so we need to take this height. The horizontal thrust is acting in the anti-clockwise direction, so it will be negative. We have already seen that in case of a simply supported arch, Hy will not come, so we only considered Va into x, which is m0. Now let's go back to the derivation. We know the formula for strain energy, mx square ds by 2ei. We can apply the value of mx here, so it will become m0 minus hy the whole square. By principle of least work, we can say that there is no settlement in the horizontal thrust. If there is no settlement, dou u by dou h will be 0. Here we have to make the differentiation. Let's see how to make the differentiation. Here we are having the formula for differentiation. If y is equal to x power n, the formula is n into x power n minus 1 divided by n. In this term, we are going to differentiate with respect to h. Here the h value is here. So we have to differentiate this term. Here n is 2. As per the formula, the 2 will be coming here. Then n minus 1, 2 minus 1. Here we are having small problem because this h value is inside the bracket and inside the square. So we have to differentiate this term again. When we differentiate this term again, m0 will become 0. For h, the differentiation is 1. Then 2 minus 1, it will become 1. We don't have to put 1 because it is already with the power of 1. Here it will become minus y. In this way, the differentiation has been done. Then we can multiply this minus y with this value. So I have to take first with the m0, then with the hy. Here it will become minus m0y. Here minus into minus, it will become plus. Then we can split these two values like this. Then we can take this m0y ds by ei on the right side, it will become positive. And then we can cut this ei and ei. Now we can take the h on the left side. Then we can take this integration of y square ds on the right side, it will come at the bottom. We have already seen that ds is equal to dx secant theta. We can apply here and cut both the secant theta values. Finally, we are getting the horizontal thrust formula, integration of m0 to y dx divided by integration of y square dx. Now we are going to end this session. Thank you for watching this video.